Hallo, it's Dumplet here. Here's an item on geometry. We have this figure on the right. So we have a quadrilateral with two right angles as shown. The blue segment here, one diagonal has length x, the other diagonal has length y. And the relationship between x and y is that 4x cubed minus 3xy squared plus y cubed equals 0, whereas to get the measure of angle theta. Now I found this question on Twitter, so credits to the owner of this question. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now before we move on to actually drawing the figure, since we kind of have to get an approximate relationship, or like, I'm not really sure. I mean, based on the figure, y seems to be greater than x, but we're not really sure because the figure may not be drawn to scale. So let's try to solve the given equation. Now, we realize that in this figure, I think we can, without lots of generality again, let x to be, let's just say 1, and try to solve for y that way. And we could kind of get the relationship from there. So for example, in the given equation, the relationship between x and y, let's assume for now that x is equal to 1. Without lots of generality, let's assume x to be 1, and we're going to solve for y here. So if x equals 1, this equation becomes 4 minus 3y squared plus y cubed. Now I'm going to rewrite it in decreasing degree, so y cubed minus 3y squared plus 4 is equal to 0. And, well, it's a cubic equation. It's a cubic polynomial equation, so we kind of have to rely on the rational root theorem. So we have a 4 here, and then the leading coefficient of technically 1. So these are the possible rational roots, so plus minus 1, plus minus 2, plus minus 4. Now, well, it's not really that difficult to see that, well, positive 2 will work here. So y equals positive 2, let's try to check it. If y equals 2, so 2 cubed, that becomes 8. 3 times 2 squared is 4, so 3 times 4, that's 12. And 8 minus 12 plus 4, and that is indeed equal to 0. So y equals 2 is a solution, so we know that the given cubic expression on the left side, it's going to contain a factor of y minus 2. Now I'm going to use synthetic division, but you can feel free to use any method to divide, but I'm going to use synthetic division to get the resulting quadratic factor. So one factor of this is going to be y minus 2, and let's just try to see if there are any other possible solutions for y. So I'm going to do synthetic division, writing down the coefficients. Again, the 0 here represents the y term. There is no y, but technically we can say it's like plus 0y, so we have to put a 0 to account for it. And we're just going to bring down the 1, multiply 2 and 1, so that's 2, negative 3 and 2, that's going to give a sum of negative 1. 2 times negative 1 is negative 2, 0 and negative 2, they add up to negative 2. Negative 2 and 2, that's negative 4, and as expected, the remainder is 0. So we have these three to be the numerical coefficients of the resulting quadratic expression. Since, well, we started with a cubic, we're going to divide it by a linear factor, y minus 2. So the resulting the other factor, it's going to be y squared minus y minus 2. So the factored form of the left side should be y minus 2 times y squared minus y minus 2 is equal to 0. Now we can further factor this actually. It's factorable into y minus 2 times y plus 1. Now, yes, we have two other solutions, y equals 2 and y equals negative 1. Now the 2, we already have it, so we technically is there's a multiplicity of 2 here for y equals 2. And we have y equals negative 1, but we're talking about distances, so I don't think negative distances would make sense here. So if x equals 1, apparently we're going to get y equals 2. So since, well, we're just assuming without lots of generality, I think we can conclude from here that, well, the ratio of x and y, it must be 1:2 because of scale factor. We can scale things up and down. Now, in fact, we can always verify this. We can try to verify that maybe y equals 2x is a solution to this one. So we can try to substitute y equals 2x, the given. Now if y equals 2x, we're going to get the following. So substituting it in, and we just have to verify this one. So it's going to become 4x cubed. Now the square of 2x here, that's 4x squared. So that's going to be minus 12x cubed. And then here, 2x cubed, that's going to become 8x cubed. So indeed, this is indeed equal to 0. So there we go. We now have at least a nice relationship between y and x. We have y is equal to 2x. So y is going to be double. So let's try to redraw the figure a little bit because it's not really drawn to scale at this point. Now the other point to make here is that, well, there are two opposite angles that are 90 degrees. So opposite angles, they're supplementary in this case, and well, they're 90 degrees. So we can say that this quadrilateral, it is going to be a cyclic one because opposite angles are supplementary. And in fact, this length of y will be the diameter of the given quadrilateral. So let's try to draw the circumcircle and try to redraw the figure. So it's going to look like a little bit of like y is indeed equal to 2x. So y is now 2x, and we know that y is the diameter of the circle. Now, since y is the diameter and y is 2 times x, so y over 2, which is going to be x, so y over 2, that's going to be x. Now y over 2, since y is the diameter, y over 2 will be the radius. So in fact, if I draw out the circumcenter, which is going to be which is going to be on the diameter, obviously. So I'm going to connect it with these 2 points. We realize that we can form actually an equilateral triangle. Although it doesn't seem to be an equilateral one, but we know it's going to be equilateral because of the fact that these two are radii, and both have a length of x because the diameter is y and y is equal to 2x. Now, what matters here is that we know the angles inside an equilateral triangle. All of them are 60s. But the most important one is this one, because as you can see here, 60 degrees, this has a central angle of 60 degrees, meaning this arc over here has a measure of 60 degrees. And what's interesting is that this angle theta here is the inscribed angle of this 60-degree arc. So we know that theta would just simply be equal to half of the intercepted arc. So 60 degrees divided by 2, and that's going to be equal to 30 degrees. And yes, indeed, that's going to be the answer. But we can try to engineer this question a little bit, not really the formal or the official way to do it, but we can try to realize that after we get the relationship between y and x, that y is 2x, we can actually do the following. Because the figure given is so generic that, for example, I'm going to use A, B, C, D to label the points. Well, the only thing that we're given is that AC is x and BD is y. And there's this angle, theta, which is technically angle ADC. So the theta that we want is angle ADC. So we can try to engineer this a little bit, just make sure that we don't violate any other given. I'm going to make side AB, let's just say it has a length of A. If I make A approach 0, that's going to allow me to say that, okay, I can make point A approach point B. Now, if that's the case, for example, if I'm going to engineer this a little bit, point A goes towards point B, so probably starting from here, it goes towards point B. Let's try to coincide them. So B and A, let's just say they're very close to each other, that it seems to be just the same point. Now, AC would be x because it was x in the beginning. So now B is equal to A. So we can kind of say here that ACD is going to be the same as BCD, now that we couldn't coincide A with B. So AC would be x, and triangle ACD would be a right triangle. Now, as mentioned a while ago, this angle theta is angle ADC, and in effect, it's going to be this angle over here. Now, combining with the fact that we know that y equals 2x, if we try to use some trigonometric ratios now, take the sine of this one, so sine theta would be equal to x over y. And x is obviously x now, and y is 2x, so x over 2x, that's going to give us 1/2. So again, sine theta here would be 1/2. So indeed, theta can be actually 30 degrees or 150 degrees, but obviously it's an acute angle here because we have a right triangle ACD. So using any of the two methods shown, we should be able to get that angle theta is going to be 30 degrees. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!